Welcome to part 2 of our product demonstrator HIACE 4x4. We are now in Brisbane. The suspension is fitted.
Done.
The headspace camper conversion is fitted and it looks fantastic. But now, the main, well, I suppose the most exciting reason why we are here. We're fitting the Egon DC hub 48 volt for the very first time.
I'm a little bit nervous about putting that in. Because we're a long way away from home and we've got exactly one prototype. So things have to go to plan. Otherwise there won't be a test drive.
This is actually why we came all this way. Today. I mean, apart from all of the other stuff. The other stuff was fun and interesting and everything. But this now is why we're here. And it, of course, features that lot there. And using that lot there, we'll be fitting that there. That is the first Egon DC hub 48 volts.
Because the cables are to interconnect all these external bits and pieces together, and that is all done on a circuit board now, rather than with wires on a board.
Right.
Let's go.
It is a revolution in DC power distribution. And I'm also going to ask Heiner, why 48 volts? Because 48 volts changes everything when it comes to 4x4s, campers and caravans. But how? Oh, that's better.
That's why I hid all the messy wiring.
There's not actually a lot I can do to help Heiner at the moment. He's in the zone. He's got his headphones on and he's buried in his work. He's been going now for a little more than 2 hours. Let's go and see how he's doing. The place we're staying at is very, very convenient. It's a very, very ordinary kind of motel, but we have this little car park right up at the top of the property, so there's nobody around, and we've actually, and the sun is shining, so it's kind of nice outside. Let's see how he's going. How you doing there?
Hello?
Hello, how you doing? Finished?
Almost.
Okay, you found the location for it.
It's not the most convenient location, but it's the one that fits.
Okay, I see all the piles of cables lying everywhere.
But I'm excited. There should be a whole lot less mess. Which I quite like.
Which is the point.
Yes. Because less mess means less complication. Easier installation. At the moment I'm just trying to extend cables in a non-professional way.
And while he does that, I'll do some other important things. I'm going to check the car over. Obviously, we had such a great opportunity yesterday to check it underneath, so I'm not going to do that again. That's not necessary. But they did do an engine oil change for us, a service on the car. I wanted to check that was done, completed. Everything looks good. All the fluid levels look good. They changed the air filter. I want to make sure that is properly down and secured. It is. Never trust your dealership, no matter who they are. Before you go on a trip, just don't. Because they're not there to handle the consequences if they forgot to do something. Got to check the wheel nuts.
Progress has been made. DC converters are hooked up. Batteries hooked up. Alternators hooked up. Feedback to the vehicle is hooked up. Wake speed is still missing. The servo still needs some cables. And the shunt, which we still have to wire for this. In the future it's not needed anymore because it will be inbuilt into the batteries. And it's just a CAN bus connection in the future. And I think in about 1.5 hours, we can have a test run.
It's 3 p.m. He said he would be finished at around 3 p.m. Let's go and see. And?
It's testing time.
Oh, wow.
I've beeped everything through. But now it's a matter of slowly connecting power bit by bit. Because we've never tested this before. I mean, it was tested in the workshop where it was made, and our engineer tested that as well. I've beeped it through now to make sure 48 and 12 volt aren't connected somewhere on the board, because this is the very first prototype. It's never been installed before, and if there would be a place on the board where 12 and 48 would connect, you know, we could very well destroy some of the electrics of the car. So it's a matter of going step by step by step now, very slowly, carefully, one fuse after another.
Okay.
Because the alternative, if we fuck this up, would be a tow truck home.
You're going to connect the battery.
Yes.
So what's going to happen now, before you do it, is that going to... Should I go there and tell you if something happens?
No, a spark would appear if something happens. Let's see.
No spark. Okay. No current.
Well, that doesn't look like there's a big short somewhere. That is good.
Okay.
All right, can you please turn accessories on?
Turn accessories on.
Not ignition, just accessories. And stay there in case you have to turn it off. Turn the engine on.
Ignition on.
Engine on. Start the engine. So now I'm gonna check if we have got power on the vehicle supply side. And we do.
Yes.
That is very good. Let's see if it pushes through to the 48 volt side. We got nothing. That is very good. Nothing here. We should have power here as well. Nice. We shouldn't have power here. Nice. Okay, very good. That is very good. Oh, look.
Oh.
It's alive!
It's alive! It's a living thing.
So that is good, because this is the alternator controller, the OE alternator controller. And that is now indicating that a fuse is blown, because there's no fuse in there. Perfect. Means we got 12 volt power there. Very nice. We've got 12 volt power there. That's good. That is the supply to the switches. We got power there as well. Okay. So when connecting this, there will be a spark. And even though I know there will be a spark, it will still scare the crap out of me as per usual. Very easy to get to. Well done in the installation.
Tiny little spark.
I'm nervous. 3 years of R&D and planning. Oh shit.
That wasn't good. Who's up here?
Yes, it was.
What's that?
That is the protection, fucking hell, for short circuits. Fucking hell, that blew up big time.
That was a big bang.
All right. Well, that part's fucked.
What are you thinking?
That's how R&D works. You keep making mistakes until you get it right. Unfortunately, I do that in front of a camera sometimes, so you get my holy shit moments where I think things have really gone wrong. But you are probably asking yourself, why are we even doing this? Why 48 volt? What is actually wrong with 12 volt? Why don't we stick to 12 volt? And the answer is exactly the same as the answer was when we went from horse and cart to combustion engine, AGM batteries to lithium batteries, solenoids to DC-DC chargers. We found a way to get the task at hand done in a much better way than we used to before. I'm thinking step by step. This is the protection against surges in the 48 volt side if the alternator has got a load dump scenario.
Which is the part that has never been tested.
Which is the part that has never been tested.
We didn't have that before with our previous drying. It's now built into the hub.
So let's check overboard again. See if something has happened to it. To fully understand what we're trying to achieve, I'll bother you with a little tiny bit of theory about electric power transmission. It's quite important to understand. I keep it short, promise. If you want to transport electric energy, the losses are sort of equivalent to the current that you're transporting. That's why overland power lines sometimes run on 400,000 volt. They try to keep the current low because the more current flows through an electric conductor, the more heat is being produced in that conductor, the more transmission losses you get. That might seem like a very small problem, but it is not when you're talking about a 200, 250, 300, 400 amp circuit, which you can get to on 12 volt. And that's where the problems start. And that's where 48 volt has got a huge advantage because now the transmission losses are only 25% of what they are on 12 volt. Sometimes even less than that under certain circumstances. Power is going to the vehicle, 150 watt, just like before. Okay. Turn the engine on. Turn the engine on. So let me give you an example where this technology really shines. 12 volt caravans with large lithium battery banks, let's say 600, 800, 1000 amp hours. You want to recharge those on the go, right? The maximum you'll get from a 12 volt vehicle charging system to a caravan, 100 amps. That's roughly where it stops. You can go to maximum extremes, but that's it. With this technology, it's easy to get 250 amp charge current into your caravan. That's 2.5 times what you can get max now, and that is not breaking a sweat at all at supplying that to your caravan. And even more so, when you turn the car off and you go for a coffee, it will keep charging from the hybrid 48 volt system in your tow vehicle. So you don't lose any time at all. Or let's say you're stationary. You've gone for a drive with your car. Now you come back. The hybrid battery in your car, the 48 volt battery, is completely full. You hook it up to the caravan, it starts charging your caravan. It starts charging with 250 amp into your caravan while your engine is not running. 12 volt can't do that. A generic great thing about 48 volt recharge time is so much faster because power transmission isn't such an issue anymore. Try to get 400 amp from a 12 volt alternator into a battery. You need 2 cables for positive and 2 cables for negative that are bigger than my thumb. Try to do that with 48 volt. You take 1 cable for positive and 1 cable for negative, and both combined together are smaller than my pinky. The weight saving that goes with that and the reduction in transmission losses in the cable is phenomenal. 12 volt can't get there. You can't get 400 amp out of an alternator and charge a lithium battery and do it in an efficient way in a 12 volt system. It's just the weight for the cables by itself, getting them through the firewall, all these little details, it is so complicated and the engineering for it is so complex. It actually makes 48 volts simpler. So once you go to these high charge currents and super fast recharge times, 48 volt is so far superior to 12 volt. 12 volt can't even touch it, not even begin to touch it. Oh, and here's one more thing. Reliability, because that's the big topic, right? It is so much more reliable than a 12-volt system. Here's the scenario. Your alternator fails. Your 48-volt alternator just fails. So there's options. One option is you can now put your 12-volt alternator back in, hook the cables back up, keep on driving. But that's complicated, right? Who wants to do that? Even better way now is you've got a massive lithium battery bank in there that supplies your vehicle. And depending on the size, you can keep on driving for days and days and days just from the power that you've still got stored in your lithium battery bank, because that is supplying your start battery, which is supplying your vehicle. You could be in the middle of the Canning stock route with a decent battery bank and drive without the alternator, drive back home. Because another thing, and it just keeps going, if you got solar on the roof, there's enough solar coming from the roof with this van in the future, because we're going to put 600 or 800 watts of solar on there. It will be enough to supply the vehicle with all the energy that it needs. So it means once the batteries are full and the sun is shining, the alternator in this will do absolutely no work whatsoever. The solar panels will be maintaining everything, and you are driving off your solar panels. Alternator not needed anymore. Try that with 12 volt.
Okay, you want me to do what? Ignition.
Turn the engine on.
Ignition on.
Engine on.
Run.
Start the engine. Yes! Look! It's doing its thing.
Is that us going? Is that showing the 48-volt battery?
Yes. We're pumping a lot into the DC loads. Turn it off again for now. Can you turn the engine back on? Ah! That was a configuration issue, because we've now got a shunt on board, and I had to program that shunt correctly because it's got different values than the Victron shunts. And now alternator is producing 2000 watt in idle. We're charging 1,500 watts into the battery. About 500 watts are going into the car. It works.
It works.
It works. So we're charging the way we want to charge. We're already up to maximum voltage. We can see the amps. That reading is now coming from the shunt built into the 48 volt hub. It works. Except for blowing the resistor up. Oh God, I'm gonna have a big beer tonight. And we can actually go to the pub because the car will drive. But I think you're gonna be the designated driver today.
Is you gonna drink a lot?
No, but enough not to be able to drive anymore, I think. I think celebration is due. The idea of that part that just blew up
Yes.
is part of the load dump scenario protection.
Yes.
So load dump means when the alternator, for whatever reason, is under full load and the battery gets disconnected, there can be a massive voltage spike in the system. And that part is there to short circuit that high voltage spike, which will only last 300 to 500 milliseconds. And I think what happened is when I put the fuse in, there was arcing. And because I was shaking, because I was so nervous, I think
there was a load dump. There was a load dump.
There was a load dump scenario. And it lasted a lot longer than a few milliseconds. And I think that activated that circuit and it short-circuited the battery. And then it went boom, it's supposed to do that because if it overloads for a longer period of time, it just blows apart and protects the circuit so nothing gets too hot and catches fire. So in a way, it did what it was supposed to do,
but it's only going to do it
when it was supposed to do it.
All right, and it can only do it once.
That can only do it once. I think what I've learned from that is that we should have something on there where you can turn the load dump protection on or off. So when you're actually fitting the board,
fitting everything, getting everything
worded,
turn it, okay.
And then when everything's installed and you're happy with it, you turn the load dump protection on. Because you will get arcing when you connect something.
Yeah.
And if that blows up every time we install the circuit board, that's not really
not
good.
A great
but
thing, feature for the product.
No, but it's R&D, it's learning about these things.
Yeah.
And that type of circuit protection hasn't been built for 48 volt circuits so far. So
again, it's a first.
We learned a valuable lesson, I think.
First.
And it didn't destroy anything else, so everything still runs the way it's supposed to be running. We're going to redesign that. All right, we are about to head off now onto our trip through the red heart of Australia. Roughly 6,000 kilometers of rough roads, corrugations, heat, dust.
You have already gained
I know.
25 to 30 millimeters, maybe more.
Yeah. The whole purpose of this is we want to field test our products before we release them into the market. We want to field test the idea. We are big believers in testing as much as possible before we release the product, because 48 volt hasn't made the best name for itself in the industry. There's a lot of issues about it still, and there's a lot of doubt if it is even a great idea, and we are going out to prove that it is a great idea and it is the next logical step. But to do that, we have to make sure that the product is reliable. So the field testing trips that we do, they are to test the reliability. We want to break things. We want to find its weaknesses, then improve on them, because this is a radically new idea that we do 48 volt with the circuit board for power distribution. The system has been built in similar ways, but we're going to standardize it and then repeat it. And that repetition and always doing it the same way, that will give us reliability. And I think that is key. And that is what we want to prove on this trip.
The traditional way of wiring up DC installations is dead and buried, because everything you see there in a traditional installation has been replaced by that. Because every component shown here is replaced by the Egon DC hub, because it eliminates the need for lugs, crimps, heat shrinks, and it eliminates the need for expertise. All those replaced with a screwdriver. What's more, built into every Egon DC hub is instant fault finding. It's a revolution. Visit egon.com.au to find out more.